Good morning, students. Today's topic is Fourier series. This is an infinite series. Okay, the Fourier series is a way of representing a periodic function. Is an infinite sum of sine and cosine functions. It is widely used in engineering, physics, electrical engineering, signal processing, and communications. Now we go to problem. Obtain the Fourier series of periodicity 2 pi for f of x equal to minus x when minus pi less than x less than 0 and f of x equal to x when 0 to 0 less than x less than pi. Otherwise, obtain the Fourier series to represent the function f of x equal to modulus of x in the interval minus pi less than x less than pi and deduce that 1 by 1 square plus 1 by 3 square plus 1 by 5 square and so on equal to pi square divided by 8. Given function f of x equal to modulus of x, define in the interval minus f of x equal to modulus of x equal to minus x in the interval minus pi to 0, modulus of x equal to x in the interval 0 to pi. Here the interval is minus pi to pi. Check whether the function is even or odd. Since modulus of x equal to modulus of minus x equal to x, that is even function, that is f of minus x equal to modulus of minus x, that is equal to x, that is f of x, that is f of, therefore f of x is an even function, therefore bn 0. Therefore Fourier series f of x equal to a naught by 2 plus summation n equal to 1 to infinity a n cos nx. First calculate a naught, that is formula 2 divided by pi 0 integral 0 to pi f of x dx. That is a naught equal to 2 divided by pi integral over 0 to pi f of x dx. That is equal to 2 pi pi integral over 0 to pi, given f of x is x in the interval 0 to pi into dx. That is equal to 2 pi pi integration of x is x square by 2 over the limit 0 to pi. That is equal to 1 by 2 to cancel, that is 1 by pi into pi square minus 0. That is equal to a naught equal to pi. Next calculate an, that is equal to 2 pi pi integral over 0 to pi f of x cos nx dx. That is equal to 2 pi pi integral over 0 to pi. Here f of x is x cos nx dx. Now using Bernoulli formula, that is 2 pi pi x into u v1 x into integration of cos nx is sin nx divided by n minus derivative of x is 1 into integration of sin nx by n is minus cos nx divided by n square over the limit 0 to pi. That is equal to 2 pi pi is common, x into sin nx divided by n plus cos nx divided by n square over the limit 0 to pi. Now put upper limit x equal to pi, that is 0 into sin pi 0 plus cos n pi minus 1 whole power n divided by n square minus lower limit 0 plus 1 cos 0 is 1 divided by n square. That is equal to 2 pi pi minus 1 whole power n divided by n square minus 1 by n square. That is 2 by n square pi into minus 1 whole power n minus 1 divided by n square. N square is common denominator. Minus 1 whole power n minus 1 is equal to minus 2 when n is odd. That is equal to 0 when n is even. Therefore an equal to minus 4 divided by n square pi if n is odd, 0 if n is even. Substituting all these, f of x equal to pi by 2 plus summation n equal to 1 to odd to infinity minus 4 divided by n square pi into cos nx. Now find the reduction. Put x equal to 0 is a point of continuity. Therefore f of 0 is 0. Since f of x equal to x, therefore f of 0 0. That is equal to the Fourier series f of x becomes 0 equal to pi by 2 minus 4 by 5. Summation n equal to odd to infinity 1 by n square. That is minus pi by 2 equal to minus 4 by pi into summation n equal to odd to infinity 1 by n square. That is pi by 2 into pi by 4 equal to summation n equal to odd to infinity 1 by n square. That is pi square by 8 equal to 1 by 1 square plus 1 by 3 square plus 1 by 5 square and so on. Therefore 1 by 1 square, 1 by 3 square, 1 by 5 square equal to 5 square by 8. Okay, this problem completed now.